Thank you very much, Professor Sweeney. Bernd, tell us in a few minutes. I'll give you 5. What we need to know.
I'll give you 5.5.
Thank you so much.
Where are the presentations again? Here, right? Yes.
You all set?
Yes.
Not that I can be much help, but.
You're good. So, thanks a lot for Chris setting the scene by telling us a little bit about what actually spatial data infrastructures are, so that we know the common grounds which we're talking about here in this session. I'd like to spend a few words on the real-time value of standardization, meaning fusing heterogeneous sensor data sources, and this ties into a few different talks which we have seen so far. Chris's, then also Ben's from yesterday, like using tweet maps for different kinds of applications such as emergency management and so on. So, let me start off my quick presentation with a short question to you guys. What we see here is basically the status quo. In the middle, you see this beautiful picture of some kind of analog emergency management, if you can call it this. Then we see manual traffic counters. We see a lot of different kind of information, which is basically there, but not available to the people. So when we see this, which is, again, the status quo, what does it tell us about real-time information sharing, about cross-domain information sharing? What does it tell us about real-time decision support, which is increasingly an important issue? Secondly, what we see is this. That's the second part of the status quo. We see a lot of different sensors and real-time data sources arising. RFID-based systems, traffic cameras, geosensor networks, and so on. So on the left-hand side, we see a lot of different sensors themselves, meaning calibrated sensors in the technical sense, measuring phenomena like nuclear radiation, air pollution, different environmental parameters, and so on. That's the one paradigm. The second one is on the right-hand side. We see different data sources arising, be it from data from geosocial networks such as Flickr, Twitter, Facebook, Foursquare, we heard about them, but also within the paradigm of people as sensors, where people would actually contribute their own subjective observations in terms of a specific area they want to contribute to. For example, the air quality in my vicinity is perceived by me, of course, subjectively, good, medium, or bad. So how do we make sense of this information? How do we create higher-level information from raw data and low-level data? That's the main question here. One solution is this, and this is just one example which I want to show. It's the live geography infrastructure. I'm not going to go into detail with it. What's important is that all of these modules which you see, the sensors, the data communication, the sensor fusion, meaning the data combination and homogenization, the modeling and analysis, plus finally the visualization, are different modules which are interconnected by open standards. Chris has mentioned the OGC. Raj is going to tell us a bit more about it in a second. I just say these standards are the important means to interconnect these modules and actually to make information usable. So, for example, if I want to exchange sensors, I just need to describe them in the same way, meaning Twitter data, but also calibrated sensors, and plug them to my analysis system, and that's about it. And that's what standardization is good for, right? So for the sake of this session here in the conference, I picked out 2 special aspects within this workflow. First of all, near real-time sensor fusion. Secondly, and I'm actually pretty much surprised that nobody touched upon that so far, semi-automated and automated quality assurance. First of all, sensor fusion. Most of you guys know what we're talking about here, right? We talk about different spatial scales in geographic data. We talk about different temporal scales. We talk about units of measure. We talk about time zones, spatial reference systems, spatial and temporal aggregation mechanisms, and so on. So how can we actually do this? Combining different data sources within an automated mechanism to make use of these data sources in real time again. Because if we think about using tweet maps for emergency management and for detecting an earthquake like it was done in Fukushima like 2 years ago, then we need this in somewhat real time or at least in near real time, right? And this is just not trivial. Second point, quality assurance, and that's my one but last slide. There are a lot of open issues. Again, if we use data from geosocial networks for these kinds of analyses, we cannot just use the data. We just have to make sure before that these data are actually somewhat representative for the purpose which we're going to use them and for the goal we want to achieve, right? So just putting them on a map is not enough. We have to think about, first of all, about establishment of formalized rule sets. So how do we store rules which are, for example, related to a floodwater event? For example, threshold detection in terms of precipitation, in terms of soil saturation, in terms of flow levels, for example. Second point, methodological agreements. So who actually tells us what quality is, what sufficient quality is for a certain application area? Which data can we use for those? So we need to build classes and categories which actually give us the right information to, as far as the validity and the usability of data is concerned for the use for a specific purpose. Furthermore, the integration of into data structures, I'm going to leave this out pretty much. It's more of a technical issue here. Then event detection mechanisms is one thing which is really, really important, meaning, again, if we touch upon floodwater events, how do we actually connect the different parameters which we measure? So how do we connect soil saturation to floodwater, to flow levels, to water levels, to precipitation? There needs to be some kind of rule-based formalism to actually be able to detect those events, meaning a floodwater event. And then one possible solution would be CEP here, complex event processing. I just mentioned it briefly, which combines data sources in real time and tries to detect events within these data sources. And finally, push-based data transmission. I'm going to leave it out due to the limited time as well. Just a technical thing as well. So the final claim and the summary here is that at first we need to go towards infrastructure-oriented instead of application-centered development in order to achieve flexibility and portability in monitoring applications. Second thing, some kind of a paradigm change needs to happen in GI developments. First of all, in terms of near real-time sensor fusion, meaning combining different kinds of data sources in near real time. And secondly, the semi-automated or automated, probably not possible at the moment, quality assurance. So make the data which we're using fit for the actual purpose and the goals we want to achieve with them. And that's how we can achieve standardized real-time information systems. Thanks very much.
Thank you, Bernd, Resch. So we've